Hello, and thank you for watching the Rolls Battery Engineering Training webinar series. Today what we're going to talk about is we're going to talk about tips and tricks for using Midnite Solar products and Rolls batteries together. We're going to specifically talk about flooded lead-acid batteries. Again, if you use these settings as described in this webinar on AGM batteries or gel batteries, you are going to damage the batteries. So please make sure that you're only using these settings for flooded lead-acid batteries. My information, my name is Steve Higgins. I'm a Technical Services Manager for the Rolls Battery Company or Surratt Battery Company. My email address is steve@surratt.com. Feel free to send me an email if you have any questions. A little bit of housekeeping. We try to keep these to about 30 to 40 minutes. This one actually should be a little closer to about 25 to 30 minutes at the most. Everybody's microphone's been muted so we don't get an echo. We don't have sound problems. So again, if you have any questions, feel free to send me an email at steve@surratt.com. If you're watching this video on YouTube, again, please send me an email to steve@surratt.com if you have any specific questions. You may post questions to the to below if you have any questions to the questions link below. Again, if you have any constructive criticism or criticism of any type, we'll be more than happy to address questions that way. Again, we're trying to make these so that people understand our batteries a little better and help out. Something else is that we have these and many other presentations available, presentations and technical documentation on my Google Drive site. If you send me an email, steve@surratt.com, request a Google Drive site, I will give you an invite, a link for it, and also a link to the YouTube site, and I will put you onto our live webinar email list if you want to attend one of those. Okay, so what we're going to talk about today is we're going to use a pretty common battery bank. That common battery bank is going to be 16 S550s connected in series parallel. So we have 8 batteries in series for a total of 16 batteries with 2 strings in parallel for a total of 856 amp hour capacity. We are going to talk about a 6,000 watt solar array connected to a couple of classic 150s, 150 volt solar charge controllers from Midnite Solar. And we are going to talk about the Whiz-Bang Junior. Unfortunately, we're not going to talk about the inverter charging because Midnite doesn't have an inverter charger at this point in time. Hopefully, they'll get their inverter finished, and then we can add this to it. A couple of the highlights we're going to hit. We're going to talk about min-max charging current, min-max discharging current, estimated peak solar production in July, January, different times of the year. We're going to mention some charging information. Just because I want to try to keep things as uniform as possible for the inverters. So on this particular system, we have this particular system. So what are the min-max charging currents for batteries? For flooded lead-acid batteries, typically you want to have one charging source that's at least 10% of the C20 rate. So if we have a 856 amp hour battery bank, we want to have roughly an 80 to 90 amp battery charger, one source. And the reason for that is that because if we have less than 10%, your absorption time extends so far that nobody ever completes an absorption time, or you're running your generator forever, or you don't have enough solar to get the batteries to a full state of charge relatively quickly. That's the number one reason for most battery failures is that customers are not properly charging their batteries. They're letting them sit in a state of discharge for a long period of time. That causes plate loss, causes problems with the batteries, and the batteries sulfate, and eventually you just can't get it back. The maximum charge current for flooded lead-acid batteries, roughly 20% of that C20 rate. So roughly on this battery bank that we're talking about, really the biggest charge source we want is 170, 172 amps of current. The reason for that is that when you have a flooded lead-acid battery, it has a little bit higher impedance, a little bit higher internal resistance than a valve-regulated battery. If you try to push more than 20 amps of current on that battery, that can cause positive plate heating and cause positive post-expansion. Heat generally causes positive post-expansion. And what that means is if you walk up to a battery bank and look at it, you'll actually see the positive post rising up out of the battery. That's generally caused to heat or excessive charging. So generally what you want is one source that's, 86 amp hours, 86 amps to 172 amps of charge rate. Maximum discharge current. Now this goes to your inverter and this goes to your system siting. One of the things you want to watch out for is your minimum maximum discharging current. So you want to try to keep your discharging current to less than the C20 rate. What that means is if we've got two parallel strings of batteries, so it's actually 42 amps here, not 21 amps. 42 amps of DC current converted to AC is about 1900 watts. If we go above that, so we load more current on that, what will happen now is that our battery bank won't last as long as advertised. So we've told our client that you're going to get roughly 10 hours of backup time at that 1900 watts of power. If the customer is running 4,000 watts of power, now what will happen is they're getting approximately half that time, 4 or 5 hours of backup time, and so the batteries aren't lasting as long. Customers having to start his generator more often, you got problems. Ideally, what you want to do is you want that C20 rate to be the max. Ideally, what you want is you want that client to be operating in that C10 or the C100 to the roughly C24, C20 rate at the most. So the lighter the load, the longer the battery is going to last. The heavier the load, the less the battery is going to last. Okay. Next thing. Estimated peak solar production. Now you've got 6,000 watts of solar panels. 6,000 watts of solar panels isn't going to produce the same in Arizona that it would in Seattle, or Seattle versus Yellowknife, or Yellowknife versus somewhere in Zimbabwe. You're going to see different productions. When you get a client that calls you up and says, I live in Albuquerque, New Mexico, and I get 8 hours of sun every day. Well, that's incorrect, because you don't get 8 hours of peak production. You may get 8 hours of light. You may get 4 to 5 hours of residual light, enough to put a little bit of current into the batteries, but it's not going to really be charging the batteries at any major source. So you need to be careful. You need to look at the quarters. You need to look at the year and see generally, what is this client going to do in January? What is this client going to do in July? What's it going to do in October? What's it going to do in March? You're going to have segmented, you're going to have different productions depending on the time of the year. So you need to take an account for that and be careful with that you're not causing problems. So, suggested system settings. So for the maximum PowerPoint charge controller, for specifically the Midnite Classics, generally the program is about the same. But let's say you've got a 6,000 watt solar array and a couple of Midnite Classics. Ideally, what we'd like you to do is we'd like you to put a current meter about halfway through the bulk charge to see exactly what current you're going to be running. These two charge controllers, they're going to be right around a peak current at 25 degrees C, right around 100 amps of current. Realistically, is 90 amps of current what you're going to see? Probably not. Between the two controllers, you're probably going to see between 75 and 90 amps of current. So I'm just throwing this number out here just to give people an idea. So if I'm going to be doing 90 amps of current, my absorption time is going to be roughly about 3.99 hours, so 4 hours for my absorption time. So I'm going to set my absorption time on both charge controllers to 4 hours, and on both charge controllers, I'm going to set my bulk absorption voltage at 60 volts DC, assuming that I have temperature compensation. If you don't have temperature compensation, you are not properly charging your batteries, depending on what the temperature of the batteries, and you could be overcharging and or undercharging your batteries. You're going to be causing problems with your battery bank, and those batteries may not be warranted if you have a failure because they're not going to be properly charged. You must always use battery temperature compensation when you're charging batteries for any solar system, regardless of where you're at. If you're in Hawaii, if you're in Washington State, if you're in British Columbia, if you're in Alberta, if you're in Nova Scotia, Tanzania, wherever you're at, you need to use battery temperature compensation, because it's not measuring the ambient temperature of the batteries, it's measuring the actual temperature of the batteries and adjusting charging voltage up or down depending on what the actual temperature of the battery is. So it's important to have that. The temperature compensation for flooded lead acid batteries is 5 millivolts per degree C per cell. Okay, so for a 48 volt system, it's going to adjust 120 millivolts for every degree Celsius above or below that 25 degree C delta. So End amps. On the charge controller, you can program end amps, the specific charge controller. End amps is important. End amps is also called return amps, end amps, or charge parameters med average. What it is that when the current going into the battery drops below 12 to 14 amps, the charge controller is going to assume that the batteries are full, and it could go to float. So you want to be careful with this, especially for sulfated batteries. Say you've got a battery bank that's 2-3 years old. Watching this video, you find out that your settings are wrong, and that explains why your batteries are not getting to a full charge. What I would actually do is I would actually disable that end amps and set it to 0 until your battery banks recover to a satisfactory, and then move that up. Move, start at 5 amps, go to 8 amps, go to 10 amps. Move that setting up until you kind of find the sweet spot for the batteries. It's going to take a little bit of tweaking, especially for an older battery versus a brand new battery, which would assume would be healthy. Last but not least, you need to make sure that you adjust your times based upon a year of production. Okay, for solar in the summertime, you're going to get better production, but you're going to see voltage losses because of heat. In the winter, you're not going to see as good a production, but there's going to be times where you're going to see better production in the summer because of the cold panels. So remember, most clients use energy more in the wintertime than they do the summertime. So a lot of times clients are adjusting their settings down in the summertime, and they're adjusting their settings up in the wintertime because they use more power in the winter than they do in the summer. Okay, so moving on. So Whiz-Bang Junior settings. Battery efficiency. I would set this at 80%. This efficiency means basically charging efficiency. If you take 100 amps out of a battery, you have to put back 120 amps to get it fully charged. So efficiency I would set to 80% and make sure your assisted charging is enabled. Because the way the Whiz-Bang Junior looks at the end amp setting, I would set your end amps at 1.5% of the C20 battery bank capacity. I would not set it at 2. And the reason for that is that if you set it at 1.5, say 12, 15 amps, instead of actually you set it about 10 to 12 amps instead of 15 to 16 amps, the time it takes for that voltage, that current to drop is going to be your 60 minutes. Remember, end amps is only 2% of the battery capacity, and it has to be there for 60 minutes before it really should be fully 100% full. So you need a time delay, and unfortunately with the Midnite product, the same thing with the Magnum product, and the same thing with the Schneider product, is you kind of play with the numbers because there is no timer setting. So make sure you understand that. So at this point, you walk away from the system. You should never check it again, right? Well, that's an unfortunate. We already kind of covered a little earlier. That's an unfortunate no. You are never done looking at settings. You are never done looking at settings for any kind of lead-based battery system. So you should always recheck it. So after the date of installation, you call your client 2-3 weeks later. You ask your client to spot check your specific gravities. This is what your client gives you: 1228, 1230, 245, 225. So your specific gravities are coming in a little low. This means that you're technically undercharging your battery bank. You need to recheck and make sure that the battery charging settings are correct. Make sure your client hasn't gone in and changed them, because a lot of times that can happen where you set them, the client calls Outback, or they call Midnite, or they call someone, they call, they get incorrect information, and so they're adjusting their charge parameters due to misinformation. You need to make sure your charging sources are actually charging as expected. Put a current clamp probe on the PV arrays and make sure that the PVs are actually producing. Check to make sure your panels are angled in the proper direction. Put a meter on to make sure that you're getting 1,000 watts, 900 watts, 800 watts per square meter of insulation on the panels. If you're not, then you need to adjust your absorption times to match what's coming in. So you need to understand that. Next thing, if you're getting these settings, if you go and you look at your system and you're getting 280, 290, 1300, 1310, 1320, you need to go back through. You're basically overcharging your batteries. If you run your settings at this higher rate for a long period of time, you're actually going to cause a higher acidic content of the electrolyte. And what that'll do is that'll wear the batteries out sooner. You want your specific gravities to be between 0.265 to 0.275, 2 to 3 hours after a full charge. If you're 260 to 265, I probably wouldn't fret over that. But if you're low or too high, you want to adjust your settings so that they get within that 0.2 to 3 hours after a full charge. So in this particular case, you would adjust your settings down. That'll help recover the specific gravities. Again, if you have any questions, feel free to email steve@threat.com. I'd be more than happy to help you out. Again, if you want to leave comments, if you're watching this on YouTube, any comments accepted. If you've got constructive criticism, we're more than happy to address your concerns. Again, email me, steve@threat.com. We'll be happy to take care of you. Thanks for listening. You guys have a good day.